I should probably record. Multiplying radical expressions. Now it says, when multiplying two radicals with the blank root, multiply the inside of the radicand. You know what word that is there? Same. Same root. Okay, if you're going to multiply a cube root times something, it better also be a cube root. You can't multiply things that are different. All right, and then we have some perfect squares. And our perfect squares are going to be, you should know your perfect squares. You should be pretty familiar. 1 squared is 1. We don't really deal with that one. 2 squared is 4. 3 squared is 9. 16. 25. What's next? 36. 49. 64. Did I miss one? 7, 8, 9, 81. Okay, and then dot, dot, dot. All right, so those are our perfect squares. You should be pretty familiar. If you see something that has a perfect square and you're taking the square root, you got to bring it out. You got to rationalize it. Perfect cubes, you might not be all that more comfortable than you are with perfect squares, but perfect cubes, you can find them the same way. What is 2 cubed? 8. 3 cubed? 27. 4 cubed? 64. 5 cubed? 125. And that's really about how high we go to. We might also do 1,000. 1,000 might show up. Okay, so those are our perfect cubes that we need to know. All right, so the first thing we're going to do is we're going to learn how to multiply radicals together. Now make sure that they are, what did I say, the same root in order to multiply. So here we go. Number 1. Square root of 2 times the square root of 8. Go ahead and multiply those together. And that gives you the square root of 16. And then go ahead and simplify. What is the square root of 16?
4.
It's 4. And so that would be your answer, 4. Okay? These are all going to be done without your calculator. Yeah. Oh, yeah, sure. That's okay. There you go. All right, let's look at number 2. They're both cube roots. Let's go ahead and multiply them together. The cube root of negative 5 times the cube root of 25 gives us the cube root of negative 125. And what is the cube root of negative 125? Do you know it?
5.
Negative 5. Yep, negative 5. Remember, we're allowed to take cube roots of negative numbers. We're not allowed to take square roots or fourth roots of negative numbers, okay? All right, here we go. Oh, speaking of that, take a look. This right here makes this problem completely invalid. You cannot take the fourth root of negative 2, and so this right here we would say has no solution. You can't evaluate it. Just move on. Same thing with the last one. Do you see how that's a cube root of 7 and a square root of 21? You cannot multiply those together, and so we would just go like that. Don't you love it when that happens? No, okay, not often. All right, so we're going to start now by simplifying some radicals. We simplified radicals last night. And those were all nice. They were like, you know, the number divided in evenly. It was beautiful. Today, not so much. Okay. All right, here we go. Number 5. We are taking the square root of 75x cubed. The first thing you need to do is deal with the number part. So the square root is 75. Okay? Am I allowed to leave it as the square root of 75? No. We did this last semester, right? 75 is what? It's 25 times 3. Okay? I write it this way. I know it's different. I think Miss Cowie and I kind of teach us a little bit different. But I always take whatever my perfect squares are and just write 25 times 3. And then I take the square root of 25, which is 5. And then leave yourself a little space here. And then put the 3, leave the 3 back in. You guys remember how to do that from last semester?
Yeah.
Yeah? Okay. Thank you, Michael. All right. Now, this x cubed. See this x cubed? It doesn't come out perfectly, does it? Something times something equals x cubed itself? No, it doesn't work. So what you're going to do is there's a couple of ways. X cubed is x times x. Okay, that'll be your x squared. And then times x. Do you agree? X cubed is x squared times x. Okay, so we're going to go 2 goes into this 2 one time. And then this one stays back. Okay, it's kind of like this. You have 25, you have 5 times 5 times 3. So I took those and I took the square root by bringing one of them out, leaving the 3 behind. Here I have x times x. I bring one of those out, leaving behind its left over. Okay, the other way that I look at this, because I don't really do it that way, I like to teach it to you that way so that you know what's happening. I like to go like this. How many times does 2 go into 3? 1 time, right? And then how many remainders do you get? 1. So I have a 1 out here and a 1 remainder here. I don't know if you like that. Some people like that better. Some people like the other way. We'll figure it out. We'll work on it. Okay, here we go. Number 6. All right, we're taking square root again. Square root of 32, x to the 4th, y to the 9th. So let's go ahead and we got to break down 32. Do you know any perfect squares that go into 32? Yeah, 4 also does, but 16 is a better one because it's bigger. So 16 times 2. All right, so let's go ahead and simplify that. When we simplify this, we're going to take the square root of 16, and what do you do to this number on the outside with it? You multiply it, right? That 2 sitting out there, 2 times this. So when I take the square root of 16, I get 4 times 2 is 8. Give yourself some room here, and then leave the 2 back in. That's just the number part. Okay, that's all the stuff we did last semester. Now we're going to do the variable part. So I like to do it this way. 2 goes into 4 how many times? 2 times. Exactly 2. Any remainders? Anybody left over? No. It's perfect. It's like having a perfect square in there. But 9, not so much. So 2 goes into 9 how many times? 4 times with 1 remainder. Okay, some people don't like that. They're like, oh, I can't divide. I can't long divide, right? It's not really long division. But so another way to think of this would be to do y to the 8th times 1, times y to the 1. And then y to the 8th is 4, leaving you with 1y behind. That's another way to look at it, okay? So it's up to you. I kind of like, 2 goes into 9, 4 times 1 remainder. So the 4's come out as this exponent, the 1 remainder stays in. It's up to you. Which one do you like better? Anybody have a preference? Neither. Wait, what? What we just did. Okay, me too. Me too. All right, now we're doing cube roots. We got to change our way of thinking. We're not looking for perfect squares in 80. What are we looking for? Perfect cubes. We're looking for perfect cubes in 80. So do you know a perfect cube that would go into 80? Yeah, look at your list. We wrote a list down of perfect cubes. Any of these numbers go into 80 evenly? 8. Yes. Okay. So here we go. We've got 8 times 10. 8 times 10 is 80. Let's take the cube root of 8. When you take the cube root of 8, you get 2, leaving behind the cube root of 10. Okay, here's the thing. You get so used to just writing a radical that you forget its index. The index is the little number here. If you wrote this as opposed to this, that's a big difference, right? The square root of 10 and the cube root of 10 are very different. They are. The square root of 25 and the cube root of 25, very different numbers. So make sure you don't forget whatever number's here, you're going to put there in your answer. All right, now let's do the letters, the variable part. And here's the way that I like to do them. I like to think 3 goes into 5. I'm going to divide 3 into 5. And how many times does it go in evenly? 1 time. And how many remainders do I get? See, they get 2 remainders, right? And I like to think of it that way because they remain back inside the radical. It's kind of cool. All right, 3 goes into 6. How many times? 2. Exactly 2. No remainders. Nobody's left back behind. And then 3 goes into 7. And if you need to, you can do this. Okay, but 3 goes into 7 exactly 2 times with 1 remainder. So z to the 2nd with 1 z left behind. Woo! And that's your answer. So we simplified this radical into there. There's no more perfect cubes in there. You're done. That's 7 problems already. That's good. How many do we have today? Infinity. No, 23. We're 1/3 of the way almost. Okay. Now, the next section, these 4 problems, it tells us to do 2 things. And we're going to do them in that order. We're going to multiply first, and then we're going to simplify them. Okay? So multiplying these, you need to know your exponent properties. Because remember with exponents, what do you do to the exponents when you multiply? the bases together, you add them. Yes, good. All right, so let's start by multiplying everything out. So here we go. 6 times 8 is 48. X cubed times x gives us x to the 4th. We're adding our exponents. And y squared times y cubed is y to the 5th. All right, so far so good. All we did was multiply. They're the same radicals. They're both square roots. We can get them together. And now we need to do the simplifying part like we just did in that previous section. So any perfect squares? Oh, you want to try this? You try it. You try the rest. You do it. What perfect square goes into 48? 16 times 3. That's a little tough one, huh? 16 times 3. All right, so you get square root of 16 is 4. That goes outside. 3 remains back in. And then there's a little 2 here. I know you can't see it because it's not there, but the square root means a little index of 2. 2 goes into 4 twice, no remainders. 2 goes into 5 twice with 1 remainder. Who got that? Before I did. Good. Yes. Those of you listening, like, I don't know, like 12 kids got that. Yeah, that's good. Okay. Here we go, number 9. We're going to multiply again. This time I've got some numbers on the outside. So the numbers on the outside are going to multiply together. 3 times 2 is 6. And then on the inside, 7 times 21. Do you need your calculator for that? 149? Oh, 147? 147? Does that sound right? 147. And then r cubed times r cubed is r to the 6th. And then s squared. Okay. Let's go ahead. 147. I'm going to divide that by 49, and I get 3. So 49. I knew it was going to be 49. You know how I knew it was going to be 49? Do you see this 21 right here? Isn't 21 7 times 3? Why is that glitching? And I already have a 7 over here. I knew it was going to be 49. So I have 7 times 3. So you can kind of break that down a little bit in your head like that. All right, so 147 is 49 times 3. And then when you take the square root of 49, you get 7. But there's that 6 out there. Remember what we do? 42. Good. You multiply. And then don't forget to leave behind the 3. All right, now we got to deal with the variables. And so, oh, they're nice, aren't they? 2 goes into this 6 exactly 3 times, and 2 goes into s exactly 1 time. So that would be your answer. Yay! Good, clean fun, huh? All right, a couple more of these. Any questions so far? You need me to slow down? We're good? We're good. Okay. I had a lot of coffee. All right, here we go. Cube roots now. Cube roots. So I've got 54 times 5 is 270. So you got the cube root of 270. And then how many x's do we have? I've got quite a few. No, I've got how many? 5. All right, 5, and then y to the 7th. There we go. Okay, now you got to switch gears in your head. You have to think perfect cubes now. Not perfect squares, but perfect cubes. And so I know that 27 is a perfect cube, and 27 times 10 is 270. So let's take the cube root of 27. What do we get when we take the cube root of 27? 3. Good. And then we leave behind the cube root of 10. The cube root of 10. Okay, don't forget that little 3 there. All right, now the rest of it. 3 goes into 5 1 time with 2 remainders. 1 time with 2 remainders. And then 3 goes into 7 2 times with 1 remainder. And that would be your answer. Are the remainder part, is that bothering you? I always worry about that. People don't really like that. See, x to the 5th is x cubed times x squared. So if I take the cube root of x cubed, I get x. And then what's left behind is the x squared. But it's just so much easier just to go 3 goes into 5, 1 time with 2 remainders. Okay, last one on this page. Here we go. We've got a binomial, and we've got a number out front. And so we're going to use what property? Starts with a D? Distributive property, exactly. So let's take this and we're going to distribute. Okay? We'll distribute and then we'll simplify. So I get rad 3 times rad 3 is rad 9. If you already knew what that was, you could write that down. And then rad 3 times rad 15 is rad 45. All right, so let's simplify these. Square root of 9 is 3. The square root of 45, we have a perfect square in there. It's 9 times 5. And so this would be 3 rad 5. Now it's very tempting to add those two things together, but you can't. They're not like terms. We have a 3, and then we have a 3 rad 5. They're not both like rad 5s, so you can't add them up. That would be the answer. All right, so you ready to flip over to the other page? Halfway done. Do you need a break? Keep going. Keep going? Some people said yes. People said keep going. Let's just go. Here we go. You take a nap when you get home. Yes. All right, here we go. We're going to divide. Now, to divide, they have to be the same index, okay? So the nth root of A over the nth root of B, you can combine those into 1 or you can split them up. This works both ways for equals. All right, so here we go. Example number 12. Divide. We're going to divide rad 50 divided by rad 2. Now, essentially what we're doing is we're really putting this underneath the same radical like that, okay? So 50 divided by 2, that's going to give us rad 25, and the square root of 25 is 5. Now, I made that a lot harder than what it needed to be. If you can look at it and go rad 50 divided by rad 2 is rad 25, which is 5. That's fine. All right, over here, same idea. Cube root of 32 divided by the cube root of 4. That's going to give us the cube root of 8. 32 divided by 4. And the cube root of 8 is 2. All right, 14. Cube roots are okay with negatives. All right, so the cube root of 81 divided by the cube root of negative 3 gives us the cube root of negative 27. 81 divided by negative 3. And what is the cube root of negative 27? Good. Negative 3. Heard it. All right, and then finally 15. Oh, a variable this time. Nice. Let's go ahead and divide these. So really we're putting these underneath the same thing, and we're simplifying inside of our radical. So we want to do 32 divided by 2. We're still inside the radical. 32 divided by 2 is 16. X cubed over x is x squared. And this is the type of thing you did last night. We're not going to do absolute values, okay? So we're going to leave that out. But the square root of 16 is 4, and the square root of x squared is x. All right, so far so good? Yes? Okay, moving on. Now we're going to do the next 3 are going to be divide and simplify. We're going to do it in that order. Anything that we can divide, we're going to do that, and then we're going to simplify our radicals, okay? So here we go. You want to try this one? You want to try it, or you want me to do it with you? We do it with you? Yeah, okay. I get paid either way, so it doesn't matter. All right, here we go. All right, so let's go ahead and divide. So we got 24 divided by 2. What do you get, 12? And m to the 4th divided by m. What do we do to our exponents? Subtract. So 4 minus 1 is m to the 3rd. That's an m. All right, now we need to simplify. So this brings us back to what we did on the front page, right, where we simplified. So we got to get a perfect square out. So we have 4 times 3. So that would give us 2 rad 3. And then our m cubed would be, we have a little index of 2. That's not written there, but it is 2. And 2 goes into 3 one time with 1 remainder. And make sure that whole thing is underneath the radical. Okay, because m cubed, remember, is m squared times m. And then you take the square root of m squared, you get m, leaving that guy behind. All right, let's try 17 now. Ooh, cubes. Here we go. Ooh, here's an interesting thing. Do you know how to tell if 162 is divisible by 3? Some of you guys know. Yes, Bryce, you do know. If you add up 1 plus 6 plus 2, what do you get? 9. And 3 goes into 9. Isn't that cool? That works that way for 3s and 9s. So if I asked you, like, does 3 go into 812? No. Those numbers add up to 11, and 3 doesn't go into 11. But if I asked you, does 3 go into 813? Yes. Yes, it does. 8 plus 9 plus 3 is 12, and 3 goes into 12. Interesting, huh? Do you care? Nah. All right, here we go. Cube root. So 162 is divisible by 3. We get 54. So we're going to get the cube root of 54. And then how many p's and q's do you have? We've got 5 minus 2 on the p's. So we've got 3 p's and 2 q's. All right, so that's the first part, is to divide. The second part is to simplify. Sorry. Man, my jokes are so stale today. All right, here we go. So what is the cube root of 54? Oh, there is no perfect cube of 54. But is there a perfect cube that goes into 54? What is it? Do you know? You're like, yes, there has to be to make this problem awesome. Anybody? 27. Michael. Michael with the brains this semester. Wow. Michael, you got so smart over the break. That's awesome. No, Michael, you did great last semester. You did really good.
I got an 89.
An 8. Oh, don't you hate that? Wouldn't you rather get an 88 than an 89?
Did you boost me up?
No. Okay, here we go. The cube root of 27 is 3, leaving the cube root of 2 behind. It was AYSO? I don't know. Oh, yeah. That's right. Yes, I was the team manager, so it's an important job. All right, here we go. Now let's find out p's. 3 goes into 3 exactly how many times? 1 time, no remainders. And then 3 does not go into 2, and so that q squared gets left behind. I kind of wrote that spaced out a little bit. It should have been more written like this, but that's okay. Just don't put it a plus in the middle. You can put like a times here if you want to, but it's all together. All right, number 18. Do you want to try one? Yes? You tried this one. All right, let's see how you did. We get the 4th root of 256 when we divide 1024 by 4. And then we get x to the what? 11? No, 14. I can't subtract. 15 minus 1, 14. Okay, so the 4th root of 256 is 4. And then 4 goes into 14 how many times evenly? 3 times. Okay, so x cubed on the outside. And how many remainders do you get? 2 remainders left over. Who got that? Yay, like 3 people. That was a tough one, huh? That was bad. Huh, that was a hard one. Anytime you get 4th roots, those get a little tricky. Okay, here comes the last section. We're almost there. We're going to rationalize. Yeah. No, it's okay. Don't say that. That's rude. You're trying to figure out how many 4s to bring out. You'd go 4 goes into 14, or how many x's to bring out. 4 goes into 14 3 times, 2 remainders. Okay, we're going to rationalize. And you've rationalized before. Okay, you're not allowed to leave radicals in the denominator. So what is the trick? What do we do here?
Times it by the...
Yes. Yes. We're going to multiply top and bottom by the radical of the denominator so that we get a, we get it rationalized. So up top we get rad 2 times rad 3 is rad 6. And in the bottom, rad 3 times rad 3 is rad 9, which is just simply 3. And that's it. You cannot divide 3 into rad 6. Rad 6 is not 6. It's rad 6, which is a gross number. All right, so here we go. Knowing that, we need to rationalize this. Now, here's the thing. When you're rationalizing, you want to simplify anything you can first. Okay? For example, I'm going to go ahead and I have x cubed and I have x. So I'm going to go 3 minus 1 gives me rad x squared up top and rad 5y on the bottom. You see that? Do that first before you rationalize. It'll make your life so much easier. And then you can even take the square root of x squared and you get x over rad 5y. So simplify anything you can before you start to rationalize. Now we need to rationalize. And rationalize is you have to not have a radical in the denominator. So we're going to multiply top and bottom by rad 5y. So that you get x rad 5y. And remember, what is rad 5y times rad 5y? 5y. Perfect. And that's it. There's nothing to simplify. X and 5y, nothing reduces here. That's your answer. Okay? Completely rationalized. Yeah, these are hard. These are going to be the toughest ones that you do. Yeah?
The y's, is just one y?
Yes. When you multiply, you get the square root of 25y squared,
Oh, okay.
which, yeah, is 5y. Just remember that, any positive number, rad a times rad a, is just going to give you a back. So you kind of think of this as a. It just gives you 5y. All right, 21. Simplify this problem first. Do you see those x's? You got to get them combined together. Shh. We have 5 minus 2 gives us x cubed. And on the bottom, we have rad 3y. Now, this is a very similar problem to the last one, like almost too much the same. Up top, we can simplify this. This is the same thing as x rad x. 2 goes into 3 one time with 1 remainder back. And on the bottom, I still have rad 3y. So to rationalize, I need to multiply top and bottom by rad 3y. So I get x on the outside, and then on the inside I have a rad x times a rad 3y gives me rad 3xy. Usually we write them in alphabetical order. It doesn't matter. xy and yx are the same thing. And then on the bottom, what are we left with? Just 3y. And that would be your rationalized answer. There's nothing to reduce. There's no more radicals in the denominator. You're good to go. All right, 2 more. The last 2 are the hardest 2. So if you've been tuning me out, you might want to tune in for this. It's pretty good. We're almost there. Now, perfect cubes are different, okay? Perfect cubes, what I did here was when I multiplied, rad 5y times rad 5, I get perfect squares, which is what I want. But perfect cubes, you want to get perfect cubes. So I'm going to rationalize this by multiplying top and bottom, not by the cube root of 3x. If I multiplied by the cube root of 3x, you know what I would get? I'd get the cube root of 9x squared. Does that help me? Does that get rid of the cube root? No, it doesn't. So what do we need to multiply top and bottom by? Yes, you know?
Yeah, it's cube root 3x squared.
Oh, close. You're so close. The x squared is correct. Yes, yes. You need to multiply by 9x squared. Now let's talk about y real quick. Some of you might be like, oh, I see y now. When I go 3 times 9, I get 27. That's a perfect cube. When I go x times x squared, I get x cubed, which is a perfect cube. So you have to multiply by something that's going to give you a perfect cube here. All right, so let's do it. We get the cube root of 18x squared. We're actually in luck because 18 doesn't have any perfect cubes and x squared doesn't either. And then on the bottom, I get the cube root. I'm going to multiply this out and then simplify it. 27x cubed. Okay? I don't want 9x squared. That's not going to help at all get rid of that cube root. So up top, we're good. Nothing can be simplified. Everything's great. And then on the bottom, the cube root of 27x cubed is 3x. And that's our answer. Now, yeah?
Instead of, well, I know you're just doing that to like show, but instead of doing the real 27 cubed, can you just do like 3x from the...
Yes. You can. Because you're multiplying by 3x and 3x squared, then it's just going to be 3x. You know what? You can always do it that way, but I'm going to show you on this one, you don't have to. I'm going to show you a better way to do this problem. You always want to use the smallest numbers, you know? I don't want to multiply by 16 because that's a pretty big number here. But what I can do is I'm sorry. I got ahead of myself. Don't do that. Let's simplify first. See these y's? Let's simplify that. So I have cube root of 5, and on the bottom, we have a cube root of 4y. So I took this y and that y. Basically, what I did was I got rid of one of them. Okay? That's basically what we just did. All right, now let's go ahead and simplify. If you didn't do it that way in the beginning, you still would at the end. It just takes a little longer. All right, so let's multiply top and bottom by the cube root of something to get rid of that cube root down there. Now you can multiply. You can think of it every time as I just have to take that 4y and square it. You can do it that way. But there's a better number that's a perfect square that 4 goes into. What is? We're going to multiply by 2 instead. 2 times 4 gives me what? 8. Isn't 8 a perfect cube? And then I need y squared. Okay? You don't have to do it this way. If you want to just think of it as just squaring that every single time, you can. It's just then you'll have to rationalize at the end, or reduce it out. All right, so here we go. We've got the cube root of 10y squared over the cube root of 8y cubed. And then to simplify that, the top is fine. There are no perfect cubes in 10 or y squared. And in the denominator, the cube root of 8y cubed is 2y.